Hey Precal, welcome to our video on transformations. So we're going to take a second to talk about what our transformations on our equation mean, and then we're going to do some examples of how that relates to our graph, like you saw on our test on questions number 10, 11, 12, and 14. So what we're going to take a look at right now is our equation. So if you take a look, what we have right here is an example of just a general equation, y'all. So these parentheses are going to represent my group. Y'all, that group could be anything, and that depends on my parent function. I could have a cubic, an absolute value, a exponential, a rational, right? And we'll talk about what those look like in a bit. So anytime I have a negative in front of my equation, what that means is that my function is going to reflect over the x-axis. I have a negative in front of my equation. The next thing I see is if I have a number outside of my group and it is a whole number, that means I have a vertical stretch. If it is a fraction or a decimal, I have a vertical compression. Next, if there is a number in front of my x inside my group, so right here, that means that I'm going to have a horizontal compression if it's a number, and a horizontal stretch if it is a decimal or a fraction. So that's the only difference between these two is that one is inside my group. So my magnitude is going to be inside my group. Horizontal stretch and compression is going to be inside. Vertical stretch and compression is going to be on the outside. Y'all, both of these are going to be at the front of my equation. The next kind of transformation we have is going to be a horizontal transformation. And y'all, that is whatever number is in my group. So on this one, I have to do the opposite. Remember, we got to do opposite. So if I have a plus 3 in here, that means I'm going to the left 3. Minus 3 means I'm going to the right 3. These numbers can be any number. This is just what I chose for this example. All right, and the last one that we're going to see is K, when it's on the outside. If this is the case, y'all, we're doing the same. So it's not opposite, you're doing the same this time. So if you have plus 7, that means I'm going up 7. If you have minus 7, that means we're going to go down 7. And again, those numbers, you can use any number. Y'all, right now, I'm going to zoom back out. If you want to screenshot this on your phone, then you can zoom in. There you go, screenshot it right there. You can zoom in and take a look to help us out when we're doing our test corrections. All right, so next let's do some examples. We got, 3 examples, y'all. So I want to think about what these mean. So on number 1, I notice that I have the rational function because I have this 1 divided by x. So the extras are this plus 6 and this minus 2. I notice that the plus 6 is inside my group, so that's just like my h. So that means I'm moving left and right. I'm going to do the opposite. So I'm going to move left 6. The minus 2 is outside my group, so that means it's the k, and I'm going to do the same. So since it's minus 2, I'm moving down 2. When I look at number 2, I want to notice a few things. I see this x in my exponent, so I know it's my exponential function. So I need to think about, what does this minus mean, what does the 3 mean, and what does the minus 1 mean? In this case, the 2 is my base, so that is not a transformation. I said when I have a negative outside of my equation, that means I'm reflecting over the x-axis. This minus 1, just like this minus 2, y'all, it's my k. So that means I'm going to move down 1. All right, and then I see this 3. When When I think about what that meant in my equation before, I know that's my magnitude. Since it's with my x, it's horizontal. And since it's a whole number, it is a horizontal compression. All right, you guys, last example. Sorry, I got a lot of stuff going on here. Is going to be this last one right here. So I see the log, so I know that is my logarithmic function. So I see the things that are not normal, that are not part of my parent function, are this -2, the 0.75, and the negative. So I know that this negative, since it's in front, tells me I'm reflecting over my x-axis. I see this 0.75 is in front, right? It's not next to my x, it's in front, so that's magnitude, but in this case it's vertical. And since it's a decimal, it'll be a vertical compression. Last thing is this -2. It's in my group, so I know I'm going side to side and I need to do the opposite. So this tells me that my function is moving right 2. If you want to pause and re-listen to any of those examples before we move on, I recommend doing that now. The next thing that we're going to see, y'all, is when we are given a parent function and its transformations and we need to draw the graph. All right, so I'm going to draw the original graph here in blue, and then we'll draw our transformed graph in green. So I notice that this is my cubic function because I have a 3 in the exponent. I know that function has a vertex at the origin, and then it's going to go up and then down. So that is my original parent function. If it moved 3 units up, I know that vertex needs to move 3 units up and 2 units to the left. 1, 2. It didn't reflect or anything, so I know those are my only 2 transformations. I can now redraw my parent function like this. If you want to take a moment to re-watch that, y'all, you are more than welcome to. My last example is going to look like this. All right, so I immediately notice a few things. I know I'm dealing with my exponential function, so I'm going to go ahead and draw that in blue. I know that my asymptote here is on the x-axis. I have an intercept at 0, 1. And I'm going to look something like this. So I now need to think about what my transform function needs to look like. I'm not going to worry right now about my x-axis. I want to worry about this left and up. All right, so since I knew I had this point, or I could take my asymptote, I need to move 2 units up. So 1, 2. So my asymptote's going to move up right here. Or this point is going to move up to 3. So I know that'll be my new intercept according to this. So I moved my 2 units up. I'm also even moving 3 units to the left. So 1, 2, 3. So this point needs to move over 3 as well. So this is my new asymptote. I'll get rid of this for us. There it goes. The last thing it tells me, so I've done my 3 units left, my 2 units up, it is reflected over the x-axis. When that happens, this point is just going to come down on the other side of my asymptote, just like that. So instead of being, if this were not reflected across my x-axis, it would look like this. But it was reflected. Uh-oh. So it's going to look like this. The green graph is my final answer. Y'all, you may watch this as many times as you need to. If you have any questions, stop and call me or Miss G over. Y'all are rock stars.